Hello, this is Clifford Jordan. I'm with Science Foresight, and welcome to the second part in our series of linear regressions. This is a data science series. We're focusing on this series in just linear regressions. Okay. Now, the first part, we looked at the data, and we also looked at a scatter plot of the data, which is right here. So here's a scatter plot. Remember, the data is purchase amounts and at a store, and people redeem coupons. And what we're going to be doing is regressing this and learning what this data means, and we're going to be doing this manually as a way to better understand how to do linear regression. Here's a couple things I want you to understand. This right here is the y-intercept, or excuse me, the y-slope-intercept formula. Let's see here. There we go. So y is equal to, and then this here number, 2.4132x. That 2.1432 is the slope of the trend line. Okay? And that slope means, if you remember, is the rise over the run. Okay? The rise, in this case, is the delta, or the change in purchase amount, and the run is the change in coupon value. So what this means is that for every $1 change in coupon value, I'm getting $2.41 in additional purchase amount. Okay? This is our sensitivity. If you remember from looking at the data, the sensitivity we programmed into it was right here. It was 3. Okay? Now with this, we created all this behavior. And remember, our idea, what we're trying to do is look at the behavior and see if we can work backwards and figure out what the true sensitivity is. Well, just by looking at the scatter plot, we see right here that this is $2.4132, not 3. Okay? So you may say, well, why isn't it 3? Well, it's because there's variance. And remember, we're looking at behavior, which is highly variant, and then work backwards and try to figure out what's really in the mind of the patron. So it's close, but it's not there 100%. Now, if I could get rid of some of the variance, that would get closer and closer. The next thing that I wanted to show you is this thing, and this is called a y-intercept. What this is the b value, and that y equals mx plus b, but what that is that's the amount of money he spends when x is 0. Well, when x is 0, that means the coupon value is 0. So when we do not give him a coupon, he's estimating that the patron will spend $103.66. That is where this trend line crosses this y-axis right here. And you can see, if you look, it's really close to $103.66. Okay? In fact, yeah, it looks like 67, not 66. I'm just teasing. But the bottom line is that is the y-intercept, and that is how we interpret it. This is the amount of money that the regression is telling us that he's spending when we do not give him a coupon. This is important to understand. The R-squared value, we're going to talk about that a little bit later, but that's kind of a measure of how accurate, I don't want to say accurate, well, it's a kind of an accuracy measurement of that the trend line is of the data itself. And this is also a function of how variant the data is. Now, when I talk about variance in the data, notice that the data is all over the place. I've got, for example, on the days that I gave him a $1 coupon, I got one way up here where he spent $127, one way down here where he spent $79. Look at this one. This one's right on the line. I can't see it, how much it was, but it's right there on the line. So he's all over the place. The variance is all over. Now imagine if we took all these points, and let me get this right, there we go, and we squashed them down to that mean trend line. That is what we call a regression to the mean. You can call this trend line like a mean trend line, but let's just call it a trend line, because the mean itself could mean different, other different things. But so let's just call this a trend line. But the whole idea of regression is squashing all that data down to the trend line, averaging it out to the trend line. Okay, let's go back to the data. And what I wanted to show you, what we're going to be doing here is we're going to be calculating a whole bunch of new columns associated with the data that will help us determine these values up here, which will help us eventually determine this, what I have in red here. What I have in red is what we're really aiming to figure out and what we're trying to calculate manually. And one is the estimated slope, that m value. And what is that? And the other one is the estimated y-intercept, the b value. So if we go back here, this is what we're trying to calculate. And we're going to be doing it manually. And this is also what we're trying to calculate, and we'll be doing that manually. Okay? So that is the estimated m value, and that's the estimated b value. Okay? All right. That said, let's go through and let's start calculating some of these rows. And we're going to do this fairly quickly. Stop the video if you need to see the formulas, and hopefully the what do you call it, the resolution will allow you to actually see it. And so I'm going to set this up at the top here. You can now see if I put it like, right here, you can see what's in that cell right here. Okay, so the first thing that we're going to do is we're going to calculate the x mean. So here's my x value, the coupon, and this is my y values, my x values, and my y values. So the first thing we're going to do is calculate the x mean. I'm going to do it right here. Now, if you notice, I already have a formula in there, and this is the formula. It's the average of that every cell in that column. Okay, so it goes from B13 to B96, which you notice highlights this whole column. And right now you can't see this over here because I colored it white because I'm a jerk. Actually, let's get out of there. So let's go ahead and uncolor it white. I'm going to color it black. There we go. So, so here is the actual formula, and excuse me. And here is the actual value, 2.27. So out of all the coupons, the mean value for the coupon is $2.27. Mean means average, by the way, in case you don't know. We're going to do the same for the y, and so that likewise is just the average of all the C column values. So that, I'm going to go ahead and uncover that, and that's $109.15. So on average, with the days he made purchases with coupons, all the days on average he spent $109.15 on average. Okay. The next thing that we're going to do is come down here. We're going to create these new columns. In this column I call the delta x mean. What it means is you take the x value and you subtract from it the mean x value. So here's the mean x value. So, and here's the x value. So if I take this value, subtract this value, that's what's going to go in here. So if we look at it, there we go. So it's taking this value here and subtracting this value up here. And notice that I put dollar signs in the value up here because that's not going to change, where the other x value will change as we propagate this down. Okay, so excuse me, get out of there. All right, so what I'm going to do is I'm going to highlight this whole row because we're going to do this for every single row, and I'm going to hit there, and there are the values of the coupon value minus the mean value. Okay, so those are the values. The next thing we're going to do is we're going to do the same thing for the y. We're going to take the y, I call this the delta y mean. We're going to take this y value and we're going to subtract the mean y value, which is up here. So if I go right here, you can see that this minus that. I put dollar signs around that because that's needs to, how do you say, it's not, it's a stationary cell. In other words, the formula as I copy it down needs to always reference the same cell. So that said, let's go ahead and highlight all, or uncover all these. I'm going to go ahead and hit there. So these are the values of the delta y mean. Okay. We needed that. The next thing we're going to do is we're going to multiply the delta x mean and the delta y mean. So we're going to multiply both of these two together, and that's going to go in this column. Okay, and sure enough, you see here it's multiplying the D13 times E13, which are these two cells, and it does that all the way down. Let's get out of here and let's highlight the answers to this, or let's uncover them, not highlight them. There you go. So, in fact, that's a way too precise. Let's just change the precision on that. Don't need it to be that precise. Okay, there we go. So that's the product of those two columns. Now what we're going to do is we're going to take this column, the delta x mean, and we're going to square it. And that goes in this column right here. So and if you look at it, here's the formula. It's just that column squared. Also, this is the same thing, but this is the y, delta y mean squared. So these two columns, so these two columns is the delta x mean squared and the delta y mean squared. So that said, let's go ahead and uncover these. All right. And then next, what we're going to do is we're going to go up here, and I'm going to sum up these two columns right here. So this is the sum of the delta x mean squared, which is this one right here. So how you do that is you take the sum of all these in this column, okay? And likewise, this is the sum of the y mean squared, which is all of these, okay? Let's go ahead and uncover these. So these are the values of the sum of the delta mean squared and sum of the delta y mean squared, okay? Next is we're going to sum up this prod, delta mean prod, right here. We're going to sum that up and put that up here. So sure, that's the sum of all these cells in the F column, okay? So let's uncover that. And now we're ready for a very, very important moment. We only got a couple more minutes before this video ends, and we got to go to the next video, and so we got to talk about the Pearson correlation. What is the Pearson correlation? Well, the Pearson correlation is this. This is the formula for the Pearson correlation, which basically says we're going to take the sum of the x value minus the x mean times the y minus y mean. Well, we've already calculated that. And we're going to divide it by the square root of the x minus the x mean squared, the sum of that, and the y minus y mean squared. We've already calculated these, we just haven't calculated the square root of that. So this here is my Pearson correlation. So this is the F7, which is my delta mean prod, dividing by the square root of F5 and F6, which are the delta mean x squared and the delta y mean x, or delta y mean squared. Anyways, that's what gives us the Pearson correlation. Now, Pearson correlation is one of those that's extremely important to what we're doing in a linear regression. It's like so key, okay? And it's set to 0.319. Or should I say that's what the value is here. All right. We're going to stop right here. And, well, before I stop, let me explain real quickly about the Pearson correlation. What the Pearson correlation basically measures is how correlated one column is, like or one variable is with another variable. So in this case, it's correlating the x's with the y's. Now, Pearson correlation goes from -1, which would be the minimum, all the way to +1, which would be the maximum. And 0 means there's no correlation at all. So something that would be positively correlated at 1 means that every time x goes up, the y goes up, okay? And approximately the same ratio amount, okay? So if x goes up this much and y goes up this much, it always seems to be the same amount. A negative correlation means every time x goes up, y goes down, it's negatively correlated, okay? So a -1 on the Pearson correlation is that. 0 means there's no correlation at all. So 0 is not good. -1 is good, and +1 is good. With that said, let's go to the next series in our tutorial on linear regressions.